In a lot of ways, Webb is like a ship. For instance, our floors are called decks, and the students work long shifts and don't get out very often. Just like a ship, we have an HVAC system. To heat our buildings, we have 2 boilers in the basement. These are fueled by municipal natural gas. Here you can see them burning. These 2 boilers heat the entire building through radiators like these. Another way the building is heated is through heating units like this one. This is also powered by the boilers and delivers warm air to the space with a plate and fin type heat exchanger and fans. Air moves around the building through a system of ducting. Ducting can come in all shapes and sizes as long as you want either rectangular or round. There are a number of exterior vents for heat rejection in the summer and exhaust of cool air in the winter. These HVAC units are currently running a refrigeration cycle in reverse, acting as heat pumps. Heat is being absorbed from the cool surroundings and added to the CAC to heat the building. A centralized system with many units is required for such a large space. There are also singular units for rooms that are not connected to the central system, like this one. With all this hot steam being piped through Webb, the pipes must be insulated to protect the casual passerby from burning themselves. The insulation reduces heat loss and makes the system more efficient. The insulation also helps make rooms like the boiler room somewhat cooler. The boilers have a lot of insulation on them to limit stray heat loss.
At Webb and onboard ships, we also need a way to refrigerate our food. Here is a vapor compression refrigeration system. Let's see how it works. Starting with point 1, the refrigerant at this point is a cool liquid vapor mixture. The refrigerant is moved through the cooled space in the evaporator. The refrigerant absorbs heat from the space and turns into a low-pressure vapor. Then the low-pressure vapor is moved through the reciprocating compressor. The fluid exits the compressor as a superheated high-pressure vapor. Then the fluid goes through a condenser. The fluid cools and heat is rejected to the surroundings. The fluid then exits the compressor as a high-pressure liquid. Then the fluid moves through a thermal expansion valve and exits as a cool liquid vapor mixture to re-enter the evaporator. Then the cycle begins again. Here's the evaporator. Condensate comes through the bottom pipe here and travels over, out of the refrigerated space, to the compressor, which is here. This is the condenser. And after that, refrigerant goes through the thermal expansion valve and then goes back to the refrigerated space.
It's running!
This is a closed-loop system for efficiency. The refrigerant used is also important for efficiency and environmental factors.
There are 3 major types of refrigerants: chlorofluorocarbons, hydrochlorofluorocarbons, and hydrofluorocarbons. Chlorofluorocarbons contain chlorine, which is extremely ozone depleting. These are also greenhouse gases. Common types of these CFCs are R11, R12, R13, and R114. These are being phased out due to their environmental impacts. Hydrochlorofluorocarbons also contain chlorine, so that they are still ozone depleting, but less so than CFCs. These are greenhouse gases. Some examples are R22, R123, and R124. R22 is a very common refrigerant. These are also being phased out due to their environmental impacts. Hydrofluorocarbons contain no chlorine, so that they have no impact on the ozone layer. However, they are still greenhouse gases. Some examples are R32, R134A, and R404A, which is the refrigerant that the Webb refrigeration systems use.